Hello, my name is Subrata Shah, and today my discussion topic is the front axle stub axles in front axle. So in previous lecture I discussed on the topic of front axle, what are the functions of the front axle, what are the types of the front axle. But now our today's topic is basically on the types of stub axles and also the steering geometry. Means the steering geometry means some parameters which is related in the steering geometries like camber, caster, kingpin, inclination, angles, curved radius, something like that. Okay, so now today I am going to start about the stub axle, types of stub axle. So you know what is stub axle? The stub axle is basically which connects the front axle to the wheels or front axle to the front wheels. So this is the function of the stub axles, main functions of the stub axles, and it is not used in basically rear axle. It is only used in case of front axle, and we are using this stub axles in four types. Number one is Iliad type stub axle, second one is reverse Iliad type stub axle, third one is Lamoni type stub axle, and fourth one is the reverse Lamoni type of stub axles. So these are the types of the stub axles. In Iliad type stub axles, the yokes, this is the Iliad type of stub axles, this one. The Iliad type of stub axles, the yoke for the king spindle is located on the ends of the I-beam. So it is only located at the one end of the I-beams, and the axle ends are forked to hold the steering knuckle extensions between them. And this is the Iliad type of stub axle, and this one is the reverse Iliad, just opposite to the Iliad type of stub axle. Have you seen any difference in between two? There is some difference because the kingpin location and also the stub axle locations with the kingpin, and in case of Iliad type stub axle, the thrust washer is placed upper portion of the stub axle, but in case of reverse Iliad type, the thrust washer is placed below the front axle. Okay, so front axle in the Iliad type, the front axles, the stub axles is placed in between the front axles, and in case of reverse Iliad type, front axle are placed in between the stub axle. This is the basic difference or the fundamental difference in between the Iliad type of stub axle and the reverse Iliad type of stub axles. The reverse Iliad type of stub axles are hinged spindle yoke on the spindle, and itself instead of on the axles. As I told you earlier that this is the difference. The stub axle is placed in between the in the front axles, and in case of reverse Iliad type, the stub axles are placed the front axle are placed in between the stub axles. Okay, the fork portion is integral with the steering knuckles also, and this type is commonly used as this facilitates on the mounting of bracing plate on the forged legs of steering knuckles also. Okay, so this is the Elliott type and reversed Elliott type of stub axles. Now Lamoni type front axles. Lamoni type front axle. In this Lamoni type front axle, instead of the yoke of the hinge, an L-shaped spindle is used, which is attached to the end of the axles by means of a pivot, and it is normally used in tractors. In tractors, we can see the Lamoni type of front axle or the Lamoni type of stub axles are used, in which is attached to the end of the axles by means of a pivot. In this, normally not used any passenger cars or any commercial cars, but it is only used in the tractors or some kind of small off-road vehicles. Okay, and this reverse Lamoni type of stub axles are basically just opposite to the Lamoni type of stub axle. In Lamoni type of stub axles, the stub axles are placed under the front axle or below the front axle, but in case of reversed Lamoni type, the stub axles is placed at the upper portion of the front axles. Okay. Now these are the types of stub axle. This is very important things for not only your semester but in competitive exams also. These 4 types of stub axles you have to remember, that is Elliott type stub axle, reversed Elliott type stub axle, Lamoni type of stub axle, and reversed Lamoni type of stub axles. Okay, now I am going to on this is the center point steering system. Okay, and it is a from this figure you can see that a vertical wheel and kingpin arrangement. This is the vertical axis of a wheel, and this is the kingpin angle, and this one is the stub axles. Okay, so these are the center point steering system, and this center point steering system has some disadvantage also, because center point steering system are nowadays this is one kind of obsolete type of steering system, and the wheels are forced or pushed by the force, and which is opposed by the resistance, and this is the force, and which is opposed by the resistance force R. This R is not captured by this picture. This is A, and this from downward force, that is the reaction force or the R, and these two forces are cause a couple force obviously, and for that if the couple force whose magnitude also become the very large, and when the front brakes are applied, so in that case when we are applied the front brakes, in that case the very large magnitude of couple force are generated, and this is called a this may be the cause of steering distortion or some dimensional problems or some linkage problems may be occurred at the use of central point steering system. And one more thing, that is the steering wheel becomes the heavy or the stiff hard becomes very hard of the distance between the kingpin and the wheel centers, and the wheel moves in an arc radius, and that's radius you can see here the denoted by the x, and around this pin also. And the large bending stress occurs on the stub axles. The large bending stress is maybe applied or maybe occurred at the stub axle and also the kingpin. So to overcome this problem, the wheel and the kingpin should have minimum possible offset distance, that is the x. When the offset is eliminated, the center line of this wheel meet the center line of the kingpin at the road surface also. The condition is called the center point steering conditions, and which can be obtained through a camber or the wheel axis inclination or the kingpin inclination. So it is mandatory to provide a camber angle or the caster angle to control the vehicles or control the movement of the vehicles very smoothly, so that we can drive the vehicle very smoothly, not creating or not occurring any problem at the time of steered. So that is very important thing. So center point steering, how the concept of camber caster is come, that is for the come from the center point steering system. So if we have to overcome this such kind of problems, we have to go for camber or the caster angle. Now this is the wheel cambers. What is camber angle? From the picture you can see the angle in between the vertical line of the axis, means the y axis, and the tire center line, means the tire vertical line with the tire center line. So this angle is known as the camber angle. Now we will discuss about some more discussion about the camber angle. If you see any car or any vehicle, you not obviously on two-wheeler, you can see the wheels are something tilted, but not like too much tilted, not like this picture. But if you follow or observe a vehicle's wheel, you can obviously check, or you can obviously see the something inclination must be there. So that inclination angle is the camber angle. And sometimes toe in toe out is also provided with the wheels, but toe in toe out are not a part of the camber angle. Okay, camber angle is the only, it is the considered as a vertical axis of the wheel with the center line of the wheel axis. The downset of the stub axle tilt the wheel outward at the top, means it is outward at the top, not in the front. In case of front, it will be in toe in or toe out. it is forming an angle between the vertical and the wheels, vertical center lines and the wheels also, which is known as the camber angle. The outward inclination is called the positive camber. There is also two types of camber. One is positive camber, another is negative camber. So outward inclination of the wheel at the top, I am once again telling you, it is considerable at the top portion of the vehicle. Okay, the is called the positive camber, and inward inclination is called the negative camber. The camber prevents the top of the wheels from tilting inward much due to excessive load or place in kingpin and wheel bearings also. Cambers on any automobile is the result of front end geometry also. Incorrect camber usually is noticed due to the abnormal tire wear along one half of the thread also. The camber is adjustable by changing the position of one end of the steering knuckle also. And although the bending stress on the stub axles and the bending stress on the stub axle, as I told you earlier, because bending stress is also a one kind of parameter, because we are using the front axle, and front axle is basically the dead axle, and it is only most of the cases of front axle are the dead axles, and these dead axles are the only role to absorbs the load or taking the loads of the front portion of the car. So the bending stresses on the stub axles are coupled and reduced, but the different rolling radius of the tire which produce a cone effect. You can see here the cone effect. It produces a cone effect which gives rise to tire wear, and another splaying action also. The equal camber angles are provided to balance these actions, and otherwise the vehicle pulls to side or the greater camber. Okay, so you have to remember that the camber angle should be equal for both the wheels, for right wheels and as well as the left wheels also. If it is not equal, then what will happen? The steering system or the car is pulled to the side of greater camber angle, which tire is those tire the tire which are providing the greater camber angle. The car is obviously pulled in that directions only. Okay, so this is the basic fundamentals of the camber. Some independent suspension system, as I told you earlier, in the suspension system, you know that the suspension system is in your 5th module, but I taught the suspension system. I teach the suspension systems in your 2nd module, because I know that the suspension system have to learn before the steering geometry, because if you don't understand the suspension, what are the types of suspension, what is independent suspension, what is dependent type of suspension, you cannot clear your concept on the steering also. So Some independent suspension system the vary of camber angles as the suspension spring deflects. This variation is form of the positive cambers. This is the variation which is from the positive cambers, with the inner tilt of the wheels also. Suspension linkage alters the camber angles when the suspension goes to jounce or rebound. Some suspension have negative camber during both jounce and rebound, so that the tire tread centers lines follows the straight path down the load. Other suspensions have positive cambers during the jounce and negative cambers during rebound also, and this keeps the tire tread surface flat on the road, and when going over the bumps and dips and during a turn, high negative camber on the outside tire helps provide cornering power as the tire deflects under the high side road due to the centrifugal force on the vehicles. And this high negative camber also causes the rapid tire wear, and the overall suspension camber is a compromise of these factors to provide the desired handling characteristics. And one more thing, that is the camber is not desirable form of consideration of a tire wear. An angle of the which exceeds 2 degree, because we all know that the camber angle should be in between 2 degree or plus minus something 1.1 or 0.2. It is in between 2 degree. It should not be crosses the 2 degree. If in between 2 degree the camber angle, the tire wears is not a big factors of consideration. If it crosses the 2 degree, then obviously the tire wears is a big consideration, and it will creates a big problem for the tire wears. So we should remember one thing, that is the tire camber angle should not crosses the 2 degree. Okay. An excessive camber gives some disadvantage also, which rise to improper contact of the wheels to the road also, because if you tilt this vehicle or provide this vehicle too much, that means one portion the portion or the contact in between wheels and the roads will be minimized. Okay, so we always try to keep this camber angle in between 2 degree. It should not be crosses the 2 degrees. Now, kingpin inclination or the swivel axis inclination. Kingpin, why it's called kingpin? King means boss. The kingpin is a big size of pin. It's not like a pin. If you see in kingpin, that is really big, and it's a cylindrical shaped. Okay, so that's why it is the boss of all king. That's why boss of all pin, that is, it's called the kingpin, king of the pin, all pins. So that's why the name is the kingpin. And what is the function of kingpin? Kingpin is basically used to attach the axles with the wheel axles with the front axle with the stub axle. So this is the function of the kingpin, and without kingpin we cannot attach or the joint the wheels with the front axles. And if the kingpin is fitted outward at the bottom, an angle in between kingpin center line and the vertical axis is produced as shown in figure. This is the kingpin swivel axis or kingpin axis, and this is the vertical line. So this axis is this angle is known as the swivel axis inclination in case of without kingpin, and in case of kingpin, that is the kingpin inclination or KPI. And this is the swivel axis inclination. Without kingpin, the axis is the swivel axis inclination. Normally a kingpin inclination in between generally 5 to 10, generally 7 to 8 degrees are commonly used to provide obtain a required offsets also. The larger angle the larger angles are necessary for a layout when the wheel is moved away from kingpin to accommodate the brakes and bearings also. And when the wheel is turned, it moves in the plane of you can see the AA plane. This AA plane moves on the AA plane such as the front of the vehicle is lifted and produces self-centering actions also, which with the vertical kingpin, a simple yoke and pin type of steering joint can be incorporated at the each end of the track rods. An inclined kingpin allows the joint to move in the plane of BB surface also, and upwards at the one end of the track rod and downwards at the others also. A ball joint is also used to reach end of the rod to permit this motion smoothly also. The kingpin inclination is also called the steering axis inclination also, SAI, steering axis inclination, and the kingpin or ball joint center line is called the steering axis center line. In next class we'll discuss about the custard angle. Today the kingpin is the last topic of my lecture, and now where we stay? Okay. The kingpin center line, if it exceeds, means it not touches, and contacts the road surface near the tire tread center lines. The distance between the point of intersection of these two center lines on the road surface is called the scrub radius. In scrub radius we have also some terms also, that is negative scrub radius or negative offset, positive offset, zero offsets. We'll discuss these topics on my next lecture. So I am ending my lectures in the topic with the kingpin inclination. Okay, thank you.